Alright, here's a program that has an array of numbers and prints them out in order. It should be simple and easy for you to understand. At this point, it has an automatic generation of the size of the for loop using this counter. It just prints the numbers. You can see it here. Obviously we glitched here. I'll just run it again and prove to you that it works. That looks good. So we want to deal with sorting. Sorting is a very common thing for programs to want to do, whether you want to sort by alphabet, sort by date, sort by some other thing. It's very common and has been extensively researched and done, and it's a good place to start and just look at how to decompose problems and generate algorithms on an ad hoc basis, which is most of what we'll be doing in robotics for the part, because we're not going to be tackling problems in a rigorous manner of investigating previous done research and all of that kind of stuff. So let's start with taking this array of numbers and making them out of order. So I'm going to do it this way because I'm not terribly ambitious. I tend towards lazy, and so I find that if I just add a number into here, it works pretty well. So now when I run this, I get numbers out of order. Turn that off. So what's the thing to do to generate numbers that are in order? Well, there's a lot of ways to look upon this, but the good way to do it would be to look up an algorithm, because it's a well handled problem, and find out what that algorithm was and then implement it. But we're going to take this in terms of breaking a bigger problem into smaller steps. So we're going to decide that the next step we want to do is to find the smallest number. We can find the smallest number in a way. We know what is the first number. So we'll put in a for loop, because we've got to be able to go through all of the numbers. And what do we need to do? We need to compare our smallest number to the number we're looking at currently. That's an if statement. If it's bigger than C, it's not the smallest number. So we have to do something. We have to go and make the smallest number equal to C. Now, there's one other thing we have to do here. We have to decide what the smallest number is set to at the beginning. The way that works to do that, because you don't know what's in your array, so if we set it equal to 0, we'd never find any other number but 0, because all the other numbers are bigger. So we're going to go and just say it is equal to the first element of array of numbers. We know that array of numbers, contains numbers that are valid for this comparison. So there we go. Now let's run this and see if I've made any silly syntax errors. I have. Array of numbers. One more try. Okay, well, we have one small problem. We've got to print the thing out. It's found the smallest number. Now this is good. So, where do we go from here? Well, one could go and look at this and say, well, what I want to do is I want to pull out the smallest number and put it into another array, and then find the next smallest number. The problem is we don't have a great way of marking smallest numbers as having already been found. We could do that. It would be a matter of keeping track of the smallest number that you have found, or the biggest number that you have found, and the smallest number that you haven't found yet. So that would be one way of doing this. But that also implies that we have two arrays. And historically speaking, computers have been so limited on memory that the notion of having the same data twice was just unacceptable. So we're not going to go down that way. If you go and you look for sorting algorithms, you won't find too many people talking about how to sort when you're allowed to have two arrays of numbers. It's just not been the way the problem has been done, and so we've sort of stuck in that historically. And the Arduino is not a big processor, and so the same limitation applies for it very much, where maybe it doesn't apply on your desktop computer that might have 16 gigs of memory. So what we're going to do now instead is we're going to move this code around. We're going to first look for the index, and to make things smart, we're going to make our name so that, because the smallest number and the smallest number index are sort of a pair of data. So we're going to denote that pairness through a naming convention. Okay, so now we've got that. Now, to know the index, we've got to know what is the index of the array, and we lose that concept in this auto loop. So we're going to instead make it auto. Well, we can keep C. We'll say semicolon. C is, sorry, I'm getting a little distracted here. C is less than 8. C++. Okay. And now C is an index, so we have to go and take this and replace it with that, because C is no longer the item, it is a pointer to the item. So it's not a pointer. Pointer has a specific meaning in program. It's an index, but it's the same thing. It doesn't tell you what the number is, it lets you get to that number. So let's see if this is compiled. Nope. Auto has no index. Yes, that is true. Okay, let's see if this compiles. Let's be smart. We'll scroll up. Non-constant of type int. Yeah, fine. I was trying to change the program as little as possible. I'm not going to investigate as to why I can't just say auto in there, but I can easily tell it what type it is. So there we go. It's an integer. It counts from 0 to 8. When we run it through, it finds the smallest number. Now, given that we've found the smallest number, the next thing we need to find is the index of the smallest number. So that's a simple modification to this. We set it equal to C. So we have the smallest number and we have where the smallest number is. So let's run that. No. We'll run it again real quickly here. Now we'll run it again. Zero, 1, 2, 3, 4. 4 is both the smallest number and the index. Okay, so now that we've got that, what do we do with the smallest number? Well, what we do with the smallest number is we move it to the front. So let's write that code down here.